I mentioned analog, and I said I would come back into it, and here's where we are. This is a basic analog telephone transmission network here. You see that there's 3 phones connected to the shared left line. There's a single shared line passing through the middle of the screen, and then 3 phones connected on the other end. The green line indicates that the conversation is currently going on between these 2 phones. What do you notice? If there's currently a conversation going on between these 2 phones, what does that eliminate the possibility of the other phones doing?
Well, they can't talk, yeah.
Right. Chip says they cannot talk. They cannot be using that line right now because the line is taken up. A dedicated path can only hold one conversation at a time. This same exact setup, once it is upgraded to digital communication, digital encoding mechanism, is much more scalable and much more effective, and I'll show you why right now. Each colored line indicates conversation going on between 2 phones. There's a green conversation, a red conversation, and a blue conversation. The shared path down the middle now is now a digital path which has packets of information. The same original streams, the green stream for example, is now broken up into small manageable sized packets that are then transferred along the shared medium, and 3 conversations can be happening simultaneously with virtually no delay or problems there. I'll talk a little bit about video communications. They're important mostly to know that streaming video takes up a lot of bandwidth. A standard audio stream like voice over IP or even analog telephone uses up about 64 kbps, that's kilobits per second. That's 64,000 ones and zeros, by the way. A standard streaming video portion uses up about 256 kbps, and that's not a very high quality video. So a standard YouTube video takes up about 320 kilobits per second. If you had 5 users on your network on their lunch break watching YouTube videos, that would use up about 1,600 kilobits per second, which would easily exceed the maximum capacity of a T1 line, which is a standard used by some companies still. Important things to remember about data, voice, and video are that communication is essential to our societies, and technological advances increase our abilities to communicate over time. Also, information can be interpreted from raw data. Also, data, voice, and video can be transferred across long distances to facilitate communication. Lastly, electrically encoded analog or digital data can be used as long as both endpoints and all intermediary points are in agreement on what type of format of data we're going to use.